How do rocket engines reignite multiple times in space? Imagine a spacecraft needing to change its path or fine-tune its orbit after reaching space. How does it turn its engines back on without crashing or losing control? That's where multiple engine reignitions come into play. Unlike engines on Earth that only fire once, space engines can be restarted many times during a mission. The secret lies in how they manage propellants, ignition systems, and engine design to work smoothly in the microgravity environment of orbit. In space, propellants like liquid hydrogen and liquid oxygen float freely inside their tanks because there's no gravity pulling them down. Before firing the engine again, the propellants must be moved to the right place, near the engine inlets. This is done using small thrusters called ullage thrusters. These tiny engines gently push the propellants to settle at the bottom of the tank, close to the engine feed lines, ensuring a steady flow. Without this step, the propellants could float away or cause uneven combustion when the engine fires. Once the propellants are settled, the ignition process begins. Rocket engines use different methods to ignite the fuel mixture. Some use pyrotechnic charges that create a spark, while others employ high-voltage spark plugs. Certain engines use hypergolic propellants that ignite instantly on contact, making ignition simpler. Torch igniters generate a hot flame to start the combustion process. These systems are designed to work reliably even after the engine has been turned off for some time, which is essential for multiple restarts. Engine design also plays a big role. Engines built for multiple ignitions are made to handle the stress of repeated heating and cooling cycles. They often include systems to precondition or chill engine parts before firing. For example, cryogenic engines that use super cold propellants like liquid hydrogen and liquid oxygen need to be carefully cooled down to prevent issues like gas bubbles forming in the feed lines. This thermal conditioning helps maintain stable flow and combustion during each restart. In the context of orbital insertion, multiple engine restarts are vital. They allow spacecraft to perform complex maneuvers such as adjusting orbits, changing altitude, or transferring between different paths. Upper stage engines like the RL-10 engine used on Centaur stages are designed specifically for multiple ignitions. These engines enable precise placement of satellites into their desired orbits and help spacecraft achieve their mission goals with accuracy. To sum up, multiple reignitions in space are made possible by managing propellants with ullage thrusters, using reliable ignition systems, designing engines to withstand repeated thermal cycles, and carefully conditioning engine components. These capabilities allow spacecraft to perform complex orbital maneuvers, making space missions more flexible and precise. This combination of techniques ensures that engines can be turned on and off multiple times, supporting everything from satellite deployment to deep space exploration.